So, ladies and gentlemen, bros and bras, here is a platform as a service in one push of a button. So, we have, I'm going to present here an example of, uh, actually, it's an example of Open Authentication 2.0, and a single sign-on mechanism built on top of it. But for that, I make this like an ecosystem, like a platform that is composed of two API server, one Mongo server, one database, two web server that hosts our web application, and two API gateway, and one container inside, like a backdoor that I provide for myself. So if I need to interact with any of this container, I simply go to the admin console and issue my comments from there. Okay, and we have two API gateway. Actually, we have three API gateway. Like this, and this is not the other one. This is the master API gateway. So any request. So let's start with what is PaaS. My idea of PaaS. So it has a lot to do with multi-tenancy. So we're developing a application, like a quite a complex application, that data processing application, basically data processing platform. So for each client, we provide their own, infrastructure that will be deployed on a cloud platform. That infrastructure is comprised of these servers, and once once the platform is set up, it will be accessible in a URL like this. Let's suppose that the name of my platform is raka.net. So, and I have a client named Fistal Flower. So once it's set up for this client, this URL will be available, and also all the other thing that makes up the platform: the authentication server, the API 1, API 2, web app 1, all the stuff, right? And for that, I have a script that automate the entire platform creation. And it's easy to think that we can execute the script from a web interface, for example. Yeah, the idea is you have to uh, first bring up, you have to run a Docker compose to bring up all those containers listed in the YAML, in this YAML document. Yeah, and so you have to bring them up. I use this command. Where the hell? Oh, this one, dro. Well, I have written some aliases to make my life easier. So dr, what is this? This is bash scripting. Dr, there it is. So it runs the Docker compose up build, and you pass on the project name. Bring up the containers, connecting front to bridge. Oh yeah, so the Kong, one of those Kong will have to, sit on two different networks. The one that face the internet and the one that face the back end. And the back end is where the Mongo database is in, the API server are in, they're the back end. So this confront will have to receive incoming requests from the internet, which in turn will went through another conf that we had in the perimeter of our network, and will forward that request to our API, our service in the backend. So yeah, so I'm putting this in two different networks and executing. Oh, here I have another script that register the API to the API gateway in the backend. So bam, I have this. Bam, 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 bam. Yep. So I'm registering API 1. I'm registering API 2. I'm registering APIs. So you know, there's not enough time here to explain this topology, but I hope you can do your own research for that. Um, blah blah. Okay, so let's just run it with this command: source start project and the name of the client. Bam. Okay. So let's check if the Docker uh, instance were created. See, these are our Dockers. So now actually we have the API up. Let's try to access it. Let's start with this one, API 1. Let's do it without any access token and see what will happen. You see, you're rejected because your request doesn't come with the required access token. So there. Okay, now the question is why? I mean, how did it happen? Well, because I have in I've configured the API gateway, this confront. No, not that one. Which one? This one. Yeah, this one. I've configured the confront to demand an oauth20 token for any request that goes to this endpoint, APIs, anything that start with APIs, right? And you see, I've already registered this one. So I put a guard here, basically, this oauth filter, basically. So now, how do I get the token? Well, you have to go through the authentication and authorizations flow, right? So your web application will have to redirect the user to this page. Hey, sorry, another client. Crystal flower. Bam. Okay. You do login here, and then you go through another step, which is the authorization, and then you will get the token. So let's try login first. Password. Whoops. Remember, you're not registered yet. So let's create the user in the database. Try out. Bam. Okay, you got the user created. Let's check it in the database. Oops, what's the IP of this Mongo? My Mongo here. Di festival flower. Come on, Mongo server. Mongo server. Bam. 0.5. Okay. Oh, I need to do the port tunneling. Hey, come on. 0.5. Bam. Yeah, because you don't want to put your database server in a publicly of in a public IP, right? So you put in a private IP, and you have, well, as an admin, you will have to, go through VPN if you have, or in this case, I simply have a SSH tunnel. Yep. Now I can access my database in localhost. Collection. Yep, the user is created. Now, let's touch the subject of single sign-on. So the idea is you just have to sign on in one place here in this URL, and once you get the token, you won't have to go through the same login process here and here. Sorry, and here. So how do I do that? Well, okay, I'll explain that later. Let's go through the login first. Yep, your login. Now you are going to authorize. I mean, as a user, you're going to authorize the access to this API. I mean, if you've done any programming with Facebook API, so you will be quite familiar with this dialog. I mean, your application, your mobile application with integration with Facebook will ask, will display a Facebook login page in case user hasn't logged into the Facebook, and then followed by the authorization dialog, where you notify the user that your application is going to access such and such information in your account, right? So this is more or less the same uh, flow here. With Facebook is authentication is based on openauth. Okay, so let's authorize it. Bam. Okay, you got the token. This is the token that you need when you access this API, right? So let's try it now. So you will have, so once you pass the authorization, you will the authorization server will redirect to this URL, the redirect URL that you specify when you register your application. And then here, this is your code actually. And here in your JavaScript code, you will have to extract this string and use that in your AJAX call to the API, right? Bam. Boom. You're not registered here. Away. What's going on? The same here. That's because each one of those microservices, the API 1 and API 2, they have their own user database. You see? where was that? Man, yeah, they have their own database, API2DB. So it expects the user information in another database, not here. Okay, so well, I haven't created that database. Well, in a real production application, you will have to create that database automatically, right? I mean, yeah, I miss one or two steps here to create the database for each one of our service that we have. So let's just do it now. API1DB, API2DB, and it expects the same user information in the same table here. Create custom user, custom user. Let's just copy it now. Okay, now let's try again. Yep, this time you get through. Okay, API 1, API 2. Now the question is, why don't we just query the same user database here instead of duplicating that information in these databases? Well, you can actually. I mean, but why I didn't do that? Well, okay, fine, because I'm trying to be purist to the idea of microservice. The idea of microservices is that it's independent. It can operate on its own without any dependencies on other microservices. I mean, by so it has its own stack up to the bottom, up from the user interface to the bottom to the database. So yeah, so that's why I duplicate. So, and it's not really a problem actually. I mean, you can come up with a mechanism for like publish subscribe. So when you register here in one single place, you you publish that event to a topic that will be picked up by all the microservices in your platform, and they will create the corresponding entry in their own database. And the other reason is why we have a separate user, because each microservice this way each microservice can have their own access control list structure, which can be completely different one to another. I mean, we can speak from experience. When we develop a monolithic platform, even if it's a pluggable, extensible, actually they share the same database. So with every addition of new module, basically you just extend from the existing database, making the relationship uh, more complex, bigger, more convoluted, and it can get really tricky when you have to reconciliate different organizational structure uh, in the same unified model. I mean, suppose your platform is, I don't know, suppose your platform has two microservices, two modules, the 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 planning, the project planning module, and the project execution module. The way you work in each of those areas naturally will be different, and naturally for that reason, uh, the way you organize your team will be different. You organize your resources will be different, so you will need a completely separate access control list. And when you try to have them together in one unified model, it's really tricky. So with microservice, we don't have to worry about it. Actually, we can focus in one single problem at a time. That's why they call it micro, and it goes very well with the yeah it applies the Unix principle. Do one thing and do it right, right? Okay, so what else? Yep, you've seen the use of Docker, the automation. What else? The use of Kong, which is a nice open source API gateway. I like it because it has lots of plugins. We've 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 seen the use of this one, and I like this one. Rate limiting. You see, um, if you've programmed something with Twitter API, you'll see the same feature, right? This is useful to avoid the denial of service attack. And what else? I saw the billing stuff, but I don't. Why can I see it here? But anyway, with the logging here, you can easily create a billing mechanism, and based on the traffic, maybe you can dynamically adjust your throttle, your rate for each client, and and bill them uh, accordingly for the access to your APIs. What else? Yeah, this is cool. Modify the stream there. Yeah, it's quite featureful. What other alternative we have uh, as API gateway? This is another open source. Um, well, it even comes with a dashboard, which is nice. You can see the traffic, the volume of access to your API. But I've tried it like just for a while, quickly. I decided to go back to Kong. What else? Yep, I think that's all. Uh, Automation, Docker Compose, Docker Compose, configuration in Kong, login, and then you get the token and use the token for your API access. So that's all. All right. See ya. What?